Hello, in this lecture we will find the radius of the semicircle. In the drawing we have triangle ABC. We know that triangle ABC is a right triangle because of the fact that angle ABC, this angle equals to 90 degrees. We also know that side AB of triangle ABC equals to 4 units. And we also know that side CD, we know that side CD, this side, or line segment CD equals to 1 unit. And we want to find out the radius of this semicircle that is actually inside triangle ABC. Okay, so first of all I present to you a new rule. I will call it rule number 1. According to rule number 1, the length of two tangents from a common external point to the circle are equal. I will read rule number 1 again. We can also call it two tangents theorem. So according to rule number 1, the lengths of two tangents from a common external point to the circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is that if you have a circle and draw the circle again. So we have this circle and we have also an external point. This point, point P, is an external point in relation to this circle because of the fact that point P is not located inside this circle nor on the circle itself. Therefore, point P is defined as external point to this circle. So if from the external point P we draw two tangents to this circle. So we have tangent we will define the touching point between the first tangent to this circle and the circle itself as point A, and then we will draw second tangent to this circle from point P, and we will define the touching point between the second tangent and the circle as point B. Then, according to rule number 1, whenever you draw two tangents to a circle from an external point, that is to say, in this case is from point P, then the length of those two tangents will be equal. The length of this, the first tangent, is actually PA, and the length of the second tangent to this circle is PB, and according to rule number 1, PA equals to PB. So whenever you draw two tangents to a circle from an external point, then the length of those two tangents will be equal to each other, that is to say PA equals to PB. Okay, so actually we can implement rule number 1 in our drawing. Because in our drawing we have from point A we have tangent AB. Tangent AB is tangent to the semicircle at point B, and we have second tangent from point A, that is external point, to the semicircle. The second tangent to the semicircle is AE, and AE, tangent AE is tangent to the semicircle at point E. Therefore, according to rule number 1, AB will be equal to AE. Okay, according to rule number 1, AB will be equal to AE. Because of the fact that from the external point A we have two tangents to the semicircle, therefore the length of those two tangents will be equal to each other, that is to say AB equals to AE. But it is given us in the question that AB equals to 3 units, so we can write here that AB equals to 3 units. So from this equality we can derive that AE also equals to 3 units. Okay, AE equals to 3 units. So AE equals to 3 units. And we will define the center of this semicircle as point O. So actually OB, line segment OB is the radius of the semicircle, I will define the radius of the semicircle as small r. OB is the radius of the semicircle because of the fact that line segment OB starts from the center of the semicircle, that is to say from point O, and ends at point B, that is a point on the semicircle itself. Therefore it is the radius. Likewise, OD will be also the radius of the semicircle because of the fact that line segment OD starts from the center of the semicircle, that is to say from point O, and ends at point D, that is a point on the semicircle itself. Therefore OD is the radius of this semicircle. And we will also join points O and E together by a straight line. Line segment OE is also the radius of this semicircle because of the fact that line segment OE starts from the center of the semicircle, that is to say from point O, and ends at point E, that is a point on the semicircle itself. Therefore line segment OE is the radius of this semicircle. Okay, so in the next step I will present to you a new rule number 2. So rule number 2 states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. I will repeat on rule number 2 again. Rule number 2 states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have a circle so we have this circle, and the center of this circle is at point O, and we also have a tangent to this circle actually AB is tangent to this circle. At this point we will define this point as point M. So the touching point between tangent AB and the circle is at point M. Then we have radius. We have a radius that is actually drawn to the point of tangency, that is to say point M. So M is the point of tangency of tangent AB with the blue circle. So if AB is tangent to the circle at point M, and we have a radius, radius OM is drawn to the point of tangency, that is to say the radius OM is drawn to point M, that is the point of tangency, then according to rule number 2, the tangent AB is perpendicular to this radius, that is to say this angle equals to 90 degrees, and this angle also equals to 90 degrees. So whenever you have a radius, like in this drawing, that is drawn to the point of tangency, that is to say this radius OM is drawn to the point of tangency, that is to say to point M, then according to rule number 1, the tangent AB is perpendicular to this radius, that is to say this angle is equals to 90 degrees, and this angle also equals to 90 degrees. Or angle BOMB equals to 90 degrees, and angle OMA also equals to 90 degrees. Okay? And we can also implement rule number 2 in our drawing, because we have the radius OE is the radius of the semicircle, and point E is the point of tangency of tangent AC with the semicircle. Okay, point E is the point of tangency. Point of tangency. And we have the radius, this radius OE, or the radius R, is drawn to the point of tangency. That is to say, this radius is drawn to the point E, that is the point of tangency. Therefore, according to rule number 2, the tangent AC will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle also will be equal to 90 degrees. Okay, so actually, triangle OEC is a right triangle. So we will focus on the right triangle, triangle OEC. So in the right triangle, triangle OEC, according to the Pythagoras theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, so according to the Pythagoras theorem, the square of the hypotenuse is OC, so OC squared equals to OE squared plus EC squared. Okay, so according to the Pythagoras theorem, if you focus on triangle OEC, in the right triangle, triangle OEC, OC squared equals to OE squared plus EC squared. That is equation number 1. So we will define EC as X, that is to say EC equals to X units in its size according to our definition. So OC, as you can see from the drawing, equals to r plus 1. OC equals to r plus 1, so OC square will be equal to r plus 1 square, and it equals to OE square. OE equals to r, as you can see from the drawing, OE equals to r. So OE square is r square, and EC is defined as x, so EC square is x square. So in total we got that equation number 1, OC square that equals to OE square plus EC square. It is actually OC is r plus 1, so OC square is r plus 1 square. OE is r, so OE square is r square. And EC equals to x, so EC square equals to x square. So in total we got that r plus 1 square equals to r square plus x square. Here we will open the brackets in equation number 1, in this side of equation number 1, and we will get that r plus 1 square is r square plus 1 plus 2r, r square plus 1 plus 2r, all equals to r square plus x square. So here we have r square in this side of the equation number 1, and we have r square on the other side of equation number 1. So we can subtract the r square from equation number 1. So r square will get cancelled, and what is left after we cancelled r square, what is left is it is actually here we have 1 plus 2r equals to x square. Okay, x square equals to 1 plus 2r. So that is equation number 1. 1 plus 2r equals to x square. So in the next step we will focus on the right triangle ABC, the big right triangle, and we will also focus on the right small triangle, triangle OEC. So on those two right triangles, triangle ABC, the big right triangle, triangle ABC, and triangle OEC, this triangle first of all, we know that angle ABC equals to 90 degrees, and angle OEC also equals to 90 degrees. Therefore, we can write down that angle ABC, this angle, equals to angle OEC, this angle, and both angles are right angles, that is to say they are equal to 90 degrees. Okay, so I will repeat again, angle ABC equals to angle ABC equals to angle OEC, and both angles are equal to 90 degrees. And we also this angle is a common angle. It belongs both to the right big triangle, triangle ABC, and this angle also belongs to the small right triangle, triangle OEC. So we can write down that angle ACB of the right big triangle, triangle ABC, angle ACB equals to angle OEC and this angle is a common angle because of the fact that it belongs to both triangles. So it is a common angle that belongs to both triangles. I will repeat again. Angle ACB equals to angle OEC. It is a common angle. This angle is a common angle that belongs to both triangles. And those two angles are also equal to each other according to third angle theorem. So write it down, angle BAC, this angle BAC, of triangle ABC equals to angle EOC, this angle of triangle EOC, according to third angle theorem. I will repeat again, angle BAC of triangle ABC, this angle equals to angle EOC of triangle EOC equals to this angle. So those two angles are equal to each other according to third angle theorem. Okay, so what is third angle theorem? Third angle theorem states that so third angle theorem states that if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles must also congruent. So I will read rule number 3 again, or the third angle theorem. You can call it also rule number 3. So according to rule number 3 of the third angle theorem, if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles must also congruent. Okay? Why? What is the reason that the third angle theorem, that the third pair of angles must be also congruent because of the fact that the sum of the angles in any triangle equals to 180 degrees. So if we have two angles of one triangle that are equal to two angles of the other triangle, then the third angle is complementary to 180 degrees. So it must be also equal to, in both triangles, because the size of the third angle will be equal to 180 degrees minus the sum of the two other angles, but the two other angles are equal in both triangles. So therefore 180 degrees minus the sum of the two angles that are equal in both triangles will be exactly the same. Those two angles will have also the same size of the third angle, because the third angle equals to 180 degrees minus the sum of the two other angles, and because of the fact that the two other angles are equal to each other in both triangles, so it will be the same angle, or the third angle will be the same size in both triangles. Okay, so this is the explanation why the third pair of angles must be equal in both triangles. Okay, so therefore we actually proved that three angles 1, 2, 3 in triangle ABC are equal to three angles 1, 2, 3 of the right small triangle OEC. Therefore, we actually proved the triangle ABC. We proved that the triangle ABC is similar to triangle OEC according to angle similarity rule. I will repeat again. We actually proved that triangle ABC is similar to triangle OEC according to angle similarity rule. So what is angle similarity rule? Angle similarity rule says that if you prove that all three angles of one triangle are corresponding equal to all three angles of the other triangle, then you actually proved that those two triangles similar to each other according to angle similarity rule. So from the fact that triangle ABC is similar to triangle OEC, we can conclude, or we can derive the following relationship between the sides of the triangles. We can derive that AB over AC in the right triangle ABC, AB over AC equals to OE over OC in the right triangle OEC. I will repeat again. Because of the fact that the triangle ABC is similar to triangle OEC, we can conclude that AB over AC in the right triangle ABC, AB over AC equals to OE over OC. In the right triangle OEC equals to OE over OC. Okay, so that will be our equation number 2. But what is AB? AB equals to 3 units. It is given us in the question. So we'll substitute AB by 3. And what is AC? AC, the hypotenuse of triangle ABC equals to 3 plus x. AC equals to 3 plus x. Okay, so AB over AC, it is actually 3 over 3 plus x, and it equals to OE. What is OE? OE is the radius of the semicircle. That is to say, it equals to R over OC. OC is the hypotenuse of triangle OEC, and OC equals to R plus 1. We know that OC equals to 1. It is given us in the question that OC equals to 1. So in total, no, DC equals to 1. Because OC is OD plus DC. OD is R and DC is 1. So in total OC equals to OD, that is R, plus DC, that is 1. So in total OC equals to R plus 1. Okay, so we actually found out that 3 over 3 plus x equals to R over R plus 1. Here we'll cross multiply equation number 2, and we will get that 3 times R plus 1 equals to R times 3 plus x. Here we'll open the brackets on both sides of the equation, and we'll get that 3R plus 3 equals to 3R plus Rx. So here we have 3R on both sides of the equation, so 3R will get cancelled. We subtract the equation number 1, 3R, and what is left after we cancel 3R is actually 3 equals to Rx. That is what is left. 3 equals to Rx. 3 equals to Rx. So that is equation number 2. But from equation number 1, so first of all, we will divide equation number 2 by x. It is allowable to divide equation number 2 by x because of the fact that x is the side S, x equals to EC, and it is one side of the right triangle, triangle OEC, therefore it must be a positive number. It can never be 0, so it is allowable to divide equation number 2 by x, and we will get that R equals to 3 over x. And in equation number 1, we found out that 1 plus 2R equals to x squared. So here we will substitute R in equation number 1 by 3 plus x from equation number 2, because R equals to 3 over x. So we'll get that 1 plus 2R, R is 3 over x, so it is 2 times 3 over x, all equals to x squared. Here 2 times 3 is 6, so we write it down. In total we got that 1 plus 6 over x equals to x squared. Here we will multiply equation number 1 by x. It is allowable to multiply equation number 1 by x because x must be a positive number. It can never be 0. So we'll get that x plus 6 equals to x cubed So we got equation number 1 that states that here we will subtract 6 and x from equation number 1, and we will get that x cubed plus minus x minus 6 x cubed minus x minus 6 equals to 0. X cubed minus x minus 6 equals to 0. So we have only x is missing. Here you can see that if we substitute x by 2, we get that 2 cubed is 8, and minus 2, 8 minus 2 is 6, and 6 minus 6 is 0. So x equals to 2 is a solution to this equation. So here we will subtract 2x squared, and then we will add 2x squared to this equality, so we will change nothing. So we will get that x cubed minus 2x squared plus 2x squared minus 2x squared plus 2x squared is 0, so we change nothing. This is 0. Minus x minus 6 equals to 0. Here we will substitute minus x by 3x minus 4, and we'll get that x cubed minus 2x squared plus 2x squared so instead of x, we write down minus 4x plus 3x minus 6 equals to 0. So here we'll take a common factor from these two expressions. The common factor of those two expressions will be x squared, and inside the root here we will have x, and here we will have minus 2 plus we will take a common factor of those two expressions. We will take a common factor of 2x, and inside the brackets we will have here x, and what is left here is, if you took 2x as a common factor, what is left is minus 2. Okay, and we will take from those two expressions a common factor of 3, and inside the brackets here we will have x minus 2 so in the next step we will take a common factor of x minus 2 over from this equation number 1, and we will get that x minus 2, and inside the brackets here we will have x squared. Here we'll have 2x, and here we will have 3, and all equals to 0. So actually, in this equation number 1, we'll have 2 solutions possible, 2 possible solutions. The first solution will be I will copy equation number 2 again, x minus 2 x squared plus 2x plus 3. So here we will have equals to 0. So here either x minus 2 will be equal to 0, that is the first solution. The second solution is that this quadratic equation in the brackets will be equal to 0. That is to say x squared plus 2x plus 3 equals to 0. Okay. There are 2 solutions possible for this equation number 1. Either x minus 2 will be equal to 0, or either this expression x squared plus 2x plus 3 will be equal to 0. So we know that the general formula of a quadratic equation is ax squared plus bx plus c equals to 0. A, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we will find f according to a special formula that says that x equals to minus b plus minus the special formula that we will use in order to find out the value of x in general is x equals to minus b plus minus root of b squared minus 4 times a times c over 2a. Okay, that is the solution of the value that for x. Okay, so inside the root we have b squared minus 4ac, and it is actually b squared minus 4ac is the discriminanta of the quadratic equation. So this discriminanta of the quadratic equation actually must be a positive number, or even 0, in order to have solution for x. So if inside the root we will have negative number, then there is no real solutions for x, and therefore the x don't have a solution, or x doesn't have a real numbers solution. So actually, therefore, if the discriminanta, that is to say b squared minus 4 times a times c, is negative, then there is no solution. So we will check. So if the discriminanta is negative, the discriminanta b squared minus 4 times ac, then there is no real solution to the for x. So we know that in our specific quadratic equation, a equals to 1, b equals to 2, and c equals to 3. Okay, so we'll check now whether if the discriminant, if it is negative, then there is no real solution to the quadratic equations. So a equals to 1, b equals to 2, c equals to 3. So b squared is 2 squared. 2 squared is 4. Minus 4 times a is 1. And c equals to 3. So in total 3 minus 12 is minus 8. Okay, so because of the fact that the discriminant is negative, therefore x doesn't have a real number solution, and x is actually the size of side EC of triangle OEC. So because of the fact that the discriminant b squared minus 4 times AC is negative, the possibility that x squared plus 2x plus 3 equals to 0 is not correct, is not a correct solution, because EC must be a positive number, and when the discriminant is negative, there is no real number solution, there is no solution that can be any real number. So therefore the possibility that x squared plus 2x plus 3 equals to 0 is not correct. So x squared plus 2x plus 3 equals to 0 is not a correct answer, so we'll cancel it. So the only answer that is left is that x minus 2 equals to 0. X minus 2 equals to 0. So if x minus 2 equals to 0, then x equals to 2. And we have in equation number 2, we found out that r times x equals to 3. So we substitute x by 2, and we will get that r times a, x is 2, equals to 0. So if x minus 2 equals to 0, then x equals to 2. So we substitute x by 2 in equation number 2. So it is r times 2 equals to 3. Here we'll divide this equality by 2, and we will get that r equals to 3 over 2 units, or it equals to 1.5 units. So we found out that the radius of this semicircle equals to 1.5 units, or 3 over 2 units. Okay, thank you very much. Before that, I will summarize the lecture. Actually, we wanted to find out the radius of this semicircle. We have triangle ABC that is a right triangle. Angle ABC equals to 90 degrees. Inside the triangle ABC we have a semicircle. The touching point between the circle and the triangle is has 2 points. The first point is point E, the second point is point B, and we'll actually want to find out the radius of this semicircle. Okay. So first of all, I presented to you a new rule number 1, and according to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have this blue circle, and from the external point, point P, we draw two tangents to this blue circle, then the lengths of those two tangents will be equal to each other. That is to say, PA will be equal to PB. Okay, so we can implement rule number 2 in our drawing, because in our drawing we have external point A. Point A is external point in relation to this semicircle because it is not located inside the semicircle nor on the semicircle. Therefore, point A is external point. It is located outside the semicircle. So from the external point, point A, we have two tangents, tangent AB and tangent AC. Tangent AE B and tangent AE and tangent AB. Tangent AE is tangent to the circle at point E, and tangent AB is tangent to the circle at point B. And according to rule number 2, whenever you draw two tangents to a circle from an external point, then the lengths of those two tangents will be equal to each other. That is to say, AB will be equal to AE. According to rule number 1, AB equals to AE. But we know that AB equals to 3 units according to what is given us in the question. So from this equality we will derive that AE also equals to 3 degrees, 3 units. AE also equals to 3 units. Okay? Then I presented to you rule number 2. Rule number 2 states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if you have this angle and tangent AB to this circle, the touching point between the circle and tangent AB is at point M. So we have point M, it is the point of tangency, and if we draw from the center of the circle radius that is drawn to the point of tangency, like in this drawing, the radius is drawn to the point of tangency, that is to say to point M. Therefore, the tangent AB will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. So we actually can implement rule number 2 in our drawing because we have the radius OE is the radius of the semicircle, and radius OE is drawn to the point of tangency, that is to say to point E, because AC tangent to the circle at point E, therefore point E is the point of tangency, and the radius OE drawn to the point of tangency, that is to say to point M. Therefore, according to rule number 2, the tangent is perpendicular to this radius, that is to say this angle equals 90 degrees and this angle also equals to 90 degrees. So we actually can conclude that triangle OEC is also a right triangle. Okay? So then we focus on the right triangle, triangle OEC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So if we implement the Pythagorean theorem in this right triangle, we will get that OC square equals to OE square plus EC square. Okay, OC square equals to OE square plus EC square. But we have already found out that OC equals to R plus 1, and OE is the radius of the circle, so OE square is R square, and CE equals to X. So in total, we got this equation. Then we subtracted R square from the equation, and we got that 1 plus 2R equals to 2X. Okay? So we have this equation number 1 plus 2R equals to X squared. And then we actually focused on the right triangle, triangle ABC, and on the right triangle, triangle OEC. So on those two right triangles, we have two angles that are equal to each other. They are both 90 degrees. We have also a common angle, angle ACB is a common angle. It belongs to both triangles, to the big triangle, triangle ABC, and also to the small right triangle, triangle OEC. Okay, so I'll repeat, those two angles are equal to each other. They are both right angles, and we have this angle that is a common angle. It belongs to both triangles. So angle C equals to angle C. And we have the third angle. Those two angles are also equal to each other according to third angle theorem. Okay, so we actually found out that all angles of triangle ABC are equal to all the angles of triangle OEC. So what is third angle theorem? Third angle theorem states that if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles must also congruent. Okay? So actually we found out that the big right triangle, triangle ABC, is similar to the small right triangle, triangle OEC, according to angle similarity rule. Okay, triangle ABC is congruent to triangle OEC. Triangle ABC is similar to triangle OEC, according to angle similarity rule. And from the fact that triangle ABC is congruent to triangle ABC, the right triangle, triangle ABC is similar to the right small triangle, triangle OEC, we can derive that AB over AC equals to DE okay. So I repeat again, AB, because of the fact that triangle ABC is similar to triangle OEC, we can derive from that fact that AB over AC equals to OE over OC. Okay? AB over AC equals to OE over OC. But we know that AB equals to 3 units and AC equals to 3 plus X. OE equals to the radius of the semicircle and OC equals to R plus 1. OC equals to R plus 1. Because multiply this equation number 2 and we got this expression. Then we open the brackets. We got this expression. We subtracted 3R from both equations. And we found out that in total 3 equals to R squared. So if we divide the equation number 2 by x, we will get that R equals to 3 over x. Okay, so we found out that R equals to 3 over x. Then we actually have equation number 1 that states that 1 plus 2R equals to x squared. And according to equation number 2, R equals to 3 over x. So we can substitute R in equation number 1 by 3 over x from equation number 2. Because R equals to 3 over x, that is the reason that we can substitute R by 3 over x in equation number 1. We substituted R by 3 over x in equation number 1 and we got that 1 plus 2 times 3 over x equals to x squared. 2 times 3 is x, is 6. So we wrote it down that R 1 plus 6 over x equals to x squared. Then we multiplied the equation number 1 by 2 and we got that x plus 6 equals to x cubed. Then we got equation number 1 that states that x squared minus x minus 6 equals to 0. If we substitute x by 2, we'll get that 8 minus 2 is 6 and 6 minus 6 is 0. So x equals to 2 solved to the equation number 1 solves. So here what we did in equation number 1 is we subtracted 2x squared and then we added 2x squared. So minus 2x squared plus 2x squared is 0, so we changed nothing. That is the reason that is allowable to add 2x squared to equation number 1 and then to subtract 2x squared. Okay. Then we substitute that x in equation number 1 by minus 4x plus 3x, that is actually minus x. We got this expression. And here we took a common factor of x squared from those two expressions, and inside the brackets we will have x minus 2. Here we took 2x as a common factor of those two expressions, and inside the brackets we have x minus 2. And here we also took 3 as a common factor of those two expressions, and what is left in the bracket is x minus 2. So actually here x minus 2 is a common factor which belongs to both triangles. So actually we got this expression x minus 2 times this quadratic equation equals to 0. So in this equation number 1 we have two solutions possible. The first solution that is that x minus 2 equals to 0, and the second solution is that x squared plus 2x plus 3 equals to 0. So the General formula for a quadratic equation is ax squared plus bx plus c equals to 0. A, B, C are the coefficients of the quadratic equation, and x is the missing variable that we want to find out, and we will find out x according to a special formula for x. And actually, inside the root we have b squared minus 4 times ac. It is the discriminant of the quadratic equation. If the discriminant is negative, there are no real solutions, and therefore this solution will not be correct, because x is the side of one side of triangle ABC. It must be a positive number, and the real and unreal solution are not correct. So we checked if the discriminant is negative or not, and we found out that the discriminant b squared minus 4 times ac in our specific quadratic equation x squared plus 2x plus 3 equals to 0, that a equals to 1, b equals to 2, and c equals to 3. So b squared is 2 squared, 2 squared is 4, minus 4 times a times c. 4 times a is 1 and c is 3, so 4 times 3 is 12. So, and in total we got that 4 minus 12 equals to minus 8. So because of the fact that we have a negative number, the discriminant is negative, there are no real solutions to the question. There are no real solutions for x, and therefore this solution is not correct, and we left only with the solution that x minus 2 equals to 0. If x minus 2 equals to 0, then x equals to 2. And we have equation number 2 that states that r times x equals to 3, so we can substitute x in equation number 2 by 2, because x equals to 2. We substituted x in equation number 2 by 2, and we got that r times 2 equals to 3. We divided this equality by 2, and we found out that r equals to 3 over 2 units, or 1.5 units. So the final solution to the question is that r equals to r, the radius of this semicircle, equals to either 3 over 2 units, or you can also present it as 1.3 units. So the solution to the question is that the radius of the semicircle equals to either 3 over 2 units, or it also can be presented like that the radius equals to 1.5 units. Okay, thank you very much.